Hello students, welcome to lesson 19. Today we're going to prove the theorem y equals mx plus b is one line passing through 0b with the slope m. We will find x and y intercepts from the standard equation and create a graph of a line. If a point is a solution to an equation, then it is a point on the line. The x-intercept is when y equals 0 or x 0, and the y-intercept is when the x equals 0 or 0y. So this is the end of our 4-point plan. So the steepness of a line is called a slope. On a proportional relationship, slope is the unit rate. Slope is the ratio of the change in the y values over the change in the x values. Any 2 points on a non-vertical line can be used to find the slope, and the line joining 2 points on a graph of the form y equals mx plus b has a slope of m. There's only one line passing through any given point with a given slope. That's what we're going to learn today. Well, actually, you can choose to learn it if you want by watching this video. This video is proof of the theorem. The proof is a step-by-step convincing argument that this theorem must be true. It's not super important to completely follow the theorem, the proof, but you must know that if I have an equation y equals mx plus b, it describes specifically a single line. There cannot be 2 lines with the exact same equation. So if I have y equals mx plus b, if the b is different or the m is different, then it's a different line. All right, so let's take a look at standard form. So you remember standard form is ax plus by equals c. So if I start here, ax, a is 2, plus by, b is 3, equals c, c is 9. So in this equation, a is 2, b is 3, c is 9. Now I'm going to find the 2 intercepts. Remember, the x-intercept is when I set y equals 0, and the y-intercept is when I set x to 0. So I'm going to start finding the y-intercept. So I'm going to set my x to 0. I'm going back to the original equation and substitute 0 in for x. 2 times 0 plus 3y equals 9. 2 times 0 is nothing, so it's gone. So I have 3y equals 9. Divide both sides by 3. So 3y divided by 3 is y. 9 divided by 3 is 3. So my y-intercept is x is 0, y is 3. So now to find the x-intercept, I set the y to 0. I know it's confusing. I'm going to go up here and replace y with 0 in the original equation. So I have 2x plus 3 times 0 equals 9. 3 times 0 is gone, so I have 2x equals 9. Divide by 2 on both sides. 2x divided by 2 is x. 9 divided by 2 is 9 over 2. So the x-intercept is 9 over 2, 0. And 9 over 2 is 4.5, if you like decimals better. So let's go ahead and graph that. So I'm going to grab the next slide here, and I have graphed that. So remember, our y-intercept was 0. When we set x to 0, y became 3. And when we set y to 0, x became 9/2, or 4.50. So I put these 2 points on, and I draw the line between them because these 2 points are solutions to this equation, right? X is 0. 2 times 0 plus 3 times 3 equals 9. 2 times 0 is 0. 3 times 3 is 9 equals 9. So this is a solution to this equation. And this is a solution to this equation. If I say 2 times 4.5 plus 3 times 0 equals 9. 2 times 4.5 is 9. 3 times 0 is 0, so 9 equals 9. So this is a solution to our equation. And every solution to our equation is on this line. Right? I can pick this point. This point is 3, 1. So I can substitute 3 for x, 2 times 3, plus 1 for y, plus 3 times 1 equals 9. 2 times 3 is 6. 3 times 1 is 3. 6 plus 3 is 9. So this point also is a solution for this equation. And if I could figure out what all of these other dots are, I could also substitute them in for the equation, and it would be a solution. Because the graph of the equation is a straight line, which means every ordered pair on this line is a solution to this equation. All right, so if a point is on the line, it is a solution to the equation. If a point is not a solution to the equation, it will not be on the line. And when an equation is in standard form, we can graph it by finding the two intercepts and drawing the line in between them. Homework for lesson 19, problems 1 through 9, do at least 2 problems, and do problem 10. Do more if you need to. Spend at least 15 minutes, or no more than 15 minutes on your homework.